Yesterday we had a training on composition tracking. Some of you were attending. I hope you enjoyed it. We heard before Tibor talking not only of mass balancing, but a lot of different usage of Sigmafine. And we will try in this presentation to show how to unlock even more potential that sometimes is hidden. It's there, lingering in your installation, but not used. Okay, we are receiving several questions, more and more diversified questions, and from different industries. So I try to recap 3 of them. The first is from upstream. So how to back allocate production from oil wells. So when you have the total oil of the day, the total gas of the day, how the different wells were performing towards this production. Or let's assume the different wells have different shareholders. How can I allocate the production, the final production, to each shareholder, taking into account the different quotas? Second question is coming from pharma company. They want to know how much is the cost of production of a production batch based on the consumption of the raw materials that were making up this batch. And finally, totally other different industry, metals and mining. They want to improve estimation of metal content in the ore. So let's assume gold, copper, valuable materials. Let's look at what we have in our portfolio and how we can use the different Sigmafine analytics to solve these issues. So we have 2 main classes of analytics. So the reconciliation analysis, which are the ones where you are more familiar with, and the tracking analysis. Regarding reconciliation analysis, the most common and the most used, I guess, 100% of you are using Sigmafine balance for mass balancing. Some of you are using energy or volume balances for the utilities. Fewer customers are using energy balance, so the coupled solution of mass and energy. We have fewer examples here. Even fewer. Can you hear me?
Say it again.
Can you hear me? Yes. Yeah, it's working. Okay. And finally, the component balance enables you to solve at once mass and chemical species. So the other class of analysis are the tracking algorithms, as I was introducing. So composition tracking, so how to follow the material that are moving in your plant from receipts downwards to the final products. And even more quality tracking to infer physical properties in places where they are not measured, or when you want an estimate and you're waiting from the lab to give you a result. So all of these, except the quality tracking, are already in your basic Sigmafine license, so you can use it from tomorrow. So let's now look deeper to the 2 classes. So we start with composition tracking. For those who are not familiar, I have a small animation. So let's assume we have some crudes stored in 2 tanks. And so we are looking at different materials mixed together in a tank. So we have a blend of crudes. And let's assume there are some movements occurring simultaneously, so there will be material coming out of this tank. The composition tracking will follow and understand which are the materials making up your movements. And suddenly these packages of materials will interact together, so they will mix. Composition tracking will do the mixing for you and evaluate in the end how much is the total feed to the unit, and this is an answer that you already got from the mass balancing, but also the distribution by each material. And this is the gain that you get when you implement composition tracking. Composition tracking can apply different mixing rules. They are all theoretical, so we don't go in the very detail of the fluid dynamics. But it's more a logical mixing, and it can handle different strategies. So from the well mixing that we have seen in the example before, to a representation of pipelines as a plug flow with first in, first out models, to stockpiles that are common with solids, where you use a last in, first out model. So it's representing packages of materials like layers that are coming and going. Let's see how this can be used in the different industries now. So the first example is an implementation of a Canadian company. And here is the representation of the Sigmafine results in a dashboard. This has been done with Tableau. They are tracking their crudes daily, and they are aggregating the results in the dashboard by the daily totals. So how is the distribution in the refinery by material day by day? And plus they are following how materials are changing in the refinery over the month. So you can see quite easily by the colors how the materials are consumed or received day by day. Second example is trying to answer the first question we posed at the beginning, so the back allocation by wells production. So here is a easy example. Let's say we have 3 wells that are producing gas, oil, and some water. You have your separation of the 3 phases. In the end, you will got a gas export pipeline, liquid oil export, and some water reinjection. Tracking algorithm will follow how the material is moving from the production of the well till the final pipeline, and will give you the distribution by well. So in the end, day by day, or in a different time frame if you want, but let's say in the accounting, the most common is the daily period, you will, it can be tracked the different production by each well. And you can see by oil and by gas in the right histogram. Similarly, if we apply some quotas by ownership of each well, the same algorithm on top can track the ownership from the well again till the production. So in the end, we can also generate a report that is saying about the production of the day, how much is belonging to each shareholder. And this, of course, for billing purposes. Third example, actually, is answering the pharma company issue. So how can we track the production of a batch following the raw material that are coming into the plant? So in this case, it's a facility it's a biopharma company. The main reactor are the fermenters that are receiving a plethora, a set of different materials that are mixed together. In some cases, the good process conditions are not matched, so you have also some waste production in between. Maybe the sterilization cycle is not going perfectly, or some residence time is not enough. So if we aggregate the results through the composition tracking over all the batch duration, you can end up in calculating the production cost by knowing the cost of each raw material and how much of the raw materials contributed to the final production, and similarly, how much is the cost associated to the waste product. Once you aggregate all this information together, this again have been published in a dashboard, this with Power BI. But the customer made a step over. So he combined this information coming from the composition tracking with the current process parameters, and deliver all this information to a machine learning algorithm to identify what was the optimal duration of the batch, which minimizes the cost of the batch itself. Now let's see the other kind of analytics, so the component balance. Component balance is still a data reconciliation analysis, unless the composition tracking, which applies several constraints. So it applies the mass constraints as a mass balance, of course, plus the conservation of the balance by chemical species. So it adds also this other dimension for the chemical species you are interested in. As optional constraint, you can also force to adding all the chemical species to add to 100%. Why this is optional? Because we have cases like metal accounting where you're not interested to reconcile the full chemical species because basically you don't know. You're not interested in reconciling the rock amount. You're just interested to reconcile the gold production. Let's see how can we use it. So let's go back to our upstream case with the 3 wells. Now we use component balance in a, let's say, creative way to reconcile not chemical species but phases. So we know that it's quite hard to measure all the 3 phases coming together, and there are expensive meters, the multi-phase flow meters, that are deployed for these purposes, trying to catch how much gas, oil, and water is coming from the wells. The accuracy, of course, is not so high compared with the accuracy that an instrument can have when it's measuring just the gas export, for example, or the oil export, when you have just one phase. So the power of Sigmafine here is that you represent with a model and you reconcile all this information together and you exploit the redundancy of information, not only of the measurement, of the total measurement itself, but of the phase also. In the end, you will end up with, and in this case we deployed a PyVision dashboard to show the data quality indicators of Sigmafine applied phase by phase to the different wells productions. And we have this matrix with colors. The higher the correction, so these numbers are high-dimensional representation of the correction applied by Sigmafine. The higher the number, the less accurate was the initial measurement. And for example, in this case, the measurement of the gas phase of wells from coming from the well number A was quite bad, and it has been marked in red. Sigmafine in this case also detected, for example, a bias. You can see here, for example, a bias between reconciled and measured data on the gas export pipeline. So this is all the kind of benefits that you can get when you apply Sigmafine to data. The redundancy helps getting more accuracy and spotting the inconsistency among the data. If we go in the detail of the wells number A, so the ones that was the least performing, what we did is also to do some Pi analytics over the measured and the reconciled values and compare the gas-oil ratio, which is the main KPI to assess the performance of a well. And we can see again a huge discrepancy between the measured and reconciled value because of this big issue on the gas phase measurement. And the indicators below are almost all pointing to red. So some action needs to be taken on this instrument specifically. Last case I present instead is metal accounting. So in this case, we have a grinding and flotation circuit where we have some measurement. Not everything is measured. The problem in this industry is that the measurement is poor and it comes sometimes. So we, through a model, through a Sigmafine model, we can again exploit the redundancy either of the mass measurement or of the analyzers to to draw the full picture around the facility. As you can see, we are using, these are the inputs, both as total flow and components. The components are defined into analyzers, which are represented with data table in the PyAsset framework. In the end, the results are displayed in this bar chart, where you can see the comparison between the measured and the reconciled value and the uncertainty bars. So I would focus more than on the value itself, how it's changed, in the fact that the uncertainty after the reconciliation is quite decreased. So when you will go to calculate the recovery yield of your plant, your KPI will have a much better accuracy. Let's say, other good points, favorable points on this side is that Sigmafine, being auditable, is either both consistent with the Amira code that is used in metals and mining industry, but also for an environmental purpose. So the calculation, for example, how much makeup water is used, so fresh water, which is giving the impact of the mining activity, and the wastewater produced by mine itself. So just to recap, let's say the use of Sigmafine as a real data engineering platform that is really cross-industry. You have seen many different cases, and that is also working in different time periods. So, for example, the meter monitoring for oil field probably will work in near real time, so typically around from 10 minutes to hourly runs, unattended. The back allocation typically can run between the hour and the daily case. Batch cost depends on the duration of the batch itself, and typically if the batch duration is longer, it's split in more fine pieces and then aggregated together. The material tracking regarding the crudes or from the semi-finished to the finished product typically is associated to the production accounting, so it's typically a daily activity, as well as for the metal accounting. So I hope to have given you a hint of how much things you can do with your Sigmafine and how many different industries we can touch. Finally, a quiz for you to answer. So if we want to model a blending operation with Sigmafine, which of the following algorithms you would like to choose to do such? Composition tracking, component balance, or quality tracking? So let's see a poll with a hand. How many would use composition tracking? How many component balance? Okay, I see. How many quality tracking? Okay, many people don't want to do blending. Okay, the answer is composition tracking for sure, to know which materials are blended together. Quality tracking I didn't speak about because there was not enough time. There is a nice presentation by E&I that you can find on our website, and I encourage to check, or come back to me if you want more information. Okay, thank you, and I don't know if you have any questions.